Hello everybody, welcome back. We've been talking about light, and chapter 28 is mostly about color, or the way that we see light. Now, this is not an art class, so I'm not going to do some of the stuff from this chapter. Like, we're not going to worry about what colors do you need to add together to get blue or stuff like that. I mean, not that that's not important, it's just you already learned that in art or some other class. What I do want you to understand is that the color that you see is dependent upon the color that comes in. Remember, light can either be reflected or retransmitted. So if I'm seeing a color on an object, like let's say I take a blue light and I shine a blue light on a red object, what color would that object be? Well, that object can only reflect red light because it's a red object. So a blue light would appear black because it would not reflect. So those are the kind of things that you would want to know. Or if I shined, if it was a transparent material, but it was only transparent to red light, and I shined a blue light on it, no light's going to pass through because the blue light will be absorbed, only the red light is retransmitted. So that's kind of what I'm going for here. Okay. So we have different colors and that we can see. In fact, we have millions of colors that we can actually discern unless you're colorblind, but we can see many different colors in general. This color spectrum is pretty huge, and as early as Newton, we've known that sun has all of these colors, and we know that from rainbows as well, and we can generate that as well. And Newton was the first one to call that, at least from my knowledge, is the first one to call this a spectrum, a color spectrum. And keep in mind that the Roy G. Biv, like that eye, that's kind of an interesting story. Red, orange, yellow, green, blue, indigo, violet. That indigo is not a color by itself. Indigo just means blue. However, when early education, when they were kind of making books and designing the color wheel, the indigo industry was a huge lobbying effort. They had lots of money, and they basically lobbied to get indigo put into the color wheel. Even though indigo is not dark blue, does not mean light blue versus dark blue. The red, orange, yellow, blue, green, violet, or green, blue, violet spectrum. It's not like a shade of blue, and indigo just means blue. So I've always had a problem with the Roy G. BIV. It should just be Roy G. Biv, not Roy G. Biv. But if that helps you remember the color wheel, then I guess it's okay. So sunlight is basically white light. It does have a little more yellow intensity, but it actually has all of the colors in it. And when you mix all of the colors together, if you transmit every color, you get white. If you absorb every color and transmit no color, you are black. When you have a light, if I see a red light, that means that light is transmitting red light. If I see a red surface, it means that surface is reflecting red light and absorbing every other light. So that's kind of what we're getting into. You already know the color spectrum. I'm not going to spend a lot of time. What's one way that Isaac Newton showed that sunlight is composed of a mixture of all the colors of the rainbow? Because he could take sunlight and convert it into that. I mean, Newton showed that the colors in the spectrum were property not of a prism but of the white light itself, because he took white light and could produce a spectrum. The sunlight produces a spectrum, a white light produces a spectrum, and if you take the spectrum and pass it through a second prism, you get white light back. So that was kind of what Newton did there. So you can have color by reflection. The color of an opaque object is the color of the light it reflects. So if I see a red object or a green leaf, and everybody's like, oh, why do they use blue lights or different colored lights if leaves are green? I've met people who think that trees prefer green light. And actually, under pure green light, a tree will eventually die because green light is what they're reflecting. They're absorbing the other colors of light. The colors that they don't reflect are what they absorb. Okay? So the colors of most objects around you are due to the light that they reflect. not the light that they absorb, unless it's something that transmits light, and then the color is based upon what it transmits. But color by reflection is what you do not absorb. And different materials have different natural frequencies. So you absorb things that kind of, if you're opaque, uh, then you can, then based upon what natural frequency you have, you absorb some light and you reflect other light. Now, if a material absorbs light of most visible frequencies and reflects red, for example, the material is red. Or you get that super dark material that I was talking about in one of my earlier videos from the Olympics, where it's absorbing almost everything. So A is reflecting all light and B is reflecting no light. Now you're of course watching this on a screen. So in reality, the white box is emitting white light and the black one is just not emitting light. So light sources give light off. Reflected objects are just, you're seeing the light being reflected. So let's do these, I guess. When red light shines on a red rose, why do the leaves become warmer than the petals? Because the petals are reflecting the red light and the leaves are absorbing the red light. So the leaves become warm and the petals don't. When green light shines on a red rose, why do the petals look black? Because the petals only reflect red light, so the green light is absorbed. Okay, so what determines the color of an opaque object? The light that it reflects. What determines the light of a transmitted object? The light that it gives off. So I'm not even going to do that section. What determines the color of a transparent object? What determines the color of a transparent object or a transmitted object is the light that it gives off. So reflective material reflects light. A transparent material allows certain light to pass through, and a light source produces certain light. And sunlight, as you can see, here's kind of like a sunlight spectrum. It is higher in the yellow, which is why we sort of see it as yellow, but all of the light is there, including ultraviolet, microwaves, radio waves. All of this energy is given off by the sun. So which visible frequencies make up the brightest part of sunlight? Well, from this, you would say kind of yellow-green. Now, if I showed you a different spectrum and I asked you what is the primary light source there, and that's kind of already shown in the study guide, I'm telling you, I will give you an image and be like, okay, what's the major light here? Or if I had a, what if I had a light source that gave off no red light and I had a red surface? What color would it appear? Well, if there's no red light for it to reflect, it would appear black. Those kind of things that you need to know. And this is the part where I'm like, well, you can worry about mixing light in, we can talk about this in art class, but you know that because it's actually different. When you see these mixed light patterns, like if you have a red, green, blue light transmitting source, you can create every color. So if it's red, green, and blue, it's going to be white. If it's blue and red, it'll be purple. If it's transmitting green and red, so this is like transmitting light. The overlap is what is being transmitted, not so like you've always been told, green and yellow and blue make green. So yellow and blue make green. This doesn't have yellow, so you can't see that. That's why I'm not a big fan of these color palette things. And it's different depending upon whether it's transmitted light or reflected light. If I take a surface, if I have it here, if I take like a transparent sheet that's red and I put a blue transparency behind it, it's going to appear black because only red can pass through this and only blue can pass through this. So if I put them together, nothing's passing through the red light can pass through the red but not the blue, so it appears black. And it's also different, yeah, so it's different upon whether it's I guess all you really need to know is that uh, the color palettes are different based upon whether it's being transmitted or reflected or uh, absorbed. We're not going to go into all of the color, um, like complementary colors and all this. For instance, a complementary color, you just need to know the definition of. When two colors are added together to produce white, they are complementary colors. For instance, yellow and blue, uh, since yellow is red and green, so I guess maybe that you can get from this. If if red and green make yellow and blue, red, and green make white, then blue and yellow make white, right? And green and magenta make white. And light blue and red make white. Those are called complementary colors. If two colors can produce white light, they're complementary colors. Went the wrong way. And you know that you can add red and blue and green. Yeah, I don't really want to get into that. We'll have, I will have some fun in class, like doing with transparencies and stuff. But I'll try and link a video for, um, like color complements. I'll link another video to go over all this stuff. So that already gets us like to color pigments. What I want you to know about color pigments, uh, it's different than transmitting light. If I have red and blue transmitting lights, so or let's say I have a red light and a green light. This is transmitting red, this is transmitting green. If I put them close enough together, I will see yellow. That's kind of like how the LEDs work in your TVs. They only need a certain number of colors to produce every color, just by the combinations. If I add yellow and green, I will see. I mean red and green, I will see yellow. But that's when it's being transmitted. So the next thing I want you to understand is there's a difference between transmission and reflection, right? So if I have a red pigment that reflects red and a green pigment that reflects green, that's a little different because they're absorbing and reflecting as opposed to transmitting. So when paints or dyes are mixed, the mixture absorbs all the frequencies each paint absorbs. So if a red surface absorbs reflects red, and a green surface only reflects green, I mix them together. If I absorb all of the red with the green and all of the green with the red, I see black when I mix those pigments. But fortunately, some of it will still be transmitted. So I talked about complementary colors. Those are colors that when you add together, you get white. The only real thing I want you to know here is subtractive colors. Subtractive colors are colors that when you put them together, so red absorbs blue and green and it reflects red. Green absorbs blue and red and reflects green. I'm trying to remember what I want you to know. We know complementary colors are two colors that when you transmit both of them, you get white. Subtractive primary colors are colors that when you add them together, you can get. So like if you have magenta, yellow, and cyan, what that means is that they are the combinations of other ones. So if I have yellow, cyan, and magenta, yellow absorbs blue, cyan absorbs red, magenta absorbs green. Whereas if I go red, green, and blue, you'll see they absorb two. So this subtractive primary colors are colors that are basically only getting rid of one color. So if I take yellow and cyan and I put them together, the yellow will absorb blue, the cyan will absorb red, so what I reflect is green. Now if I take a yellow and a blue light, yellow plus blue are complementary colors, so they will produce white light. Yellow light and blue light produce white light. But yellow and cyan, which is a bluish color, yellow pigment and cyan pigment, the yellow gets rid of the blue, the cyan gets rid of the red. Yellow and bluish pigment, when I put them together, yellow and blue give green. So that's the subtractive colors are what we're more familiar with, how we can mix colors to produce other colors. We're not as familiar with the complementary colors, or the colors that when we add them together, we get white. So where was that at? The color wheel. Yeah, way over here. So yellow and blue make white, but cyan is kind of this blue over here. All right, so yellow and cyan kind of mix to make, if I take this cyan part and I add the yellow part, I'm still going to get that white. See where they interact. So here's blue, blue and yellow make white. Blue and cyan, or yellow and cyan are going to make a whitish color, but that's when it's being transmitted color. When it's being reflected color, we all know that yellow and blue make green, but that's because of this subtractive. So this is complementary colors when they're being transmitted, and subtractive is when we're using pigments. And subtractive colors do act differently because because they're absorbing only certain light, and whatever light they both reflect is the light that makes it through. That's really the message I was trying to get across there. So which visible frequencies are absorbed by a mixture of paints and dyes? It just has to do with whatever the dyes are. And you can see that when you mix them together, you can create all kinds of fun colors. This is kind of how a jet printer works. You get magenta, yellow, cyan, and then you do some black for the contrast. You put them together and you can make every color. So we use RGB for transmitted light, and we use magenta, yellow, cyan for reflected light, because complementary colors and subtractive colors don't work the same way. So that's just the color part. I'm going to do one more video for this series talking about why different things are the color that they are.